Okay, so what Mike has done, Mike has said 1 through to 11. Is that odd or is that even? It's odd, isn't it? So that means that we will have 5 terms plus the middle term, won't we? Okay. So what that would be 2 plus 4. Then we're going to go plus dot 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 dot. Then the last one will be 11. The second and last one will be 20, won't it? Okay? So the first and last one will give us 24. Second and the second and last one will be 24 also, won't it? The problem is we will have 10 of these pairs plus the middle one. The middle one will be the 6th term, won't it? Yes? So this 6th term will have no pair. So this will be n is equal to 6, and that will be plus 12, won't it? So what this will give us, this will give us 5 times 24. So what's going to happen is we're going to go 5 times 24 plus our middle term, which will be 6, plus our 3 times 11. Okay, so this is going to be 5 times 24, that's going to give 120. Oh yes, sorry, you are right. Plus 12, n is 6. Plus 165, is it? Okay, so that's 40, 45. You are right, 165. Everyone's happy with that?
Yes.
Do you want me to check it on the calculator? Happy. You don't need to practice these, do you? You've done. Okay, what happens is here n is 1 through to 11. We have 11 terms. 11 is odd, isn't it? So then what we do, we know we have 5 terms. Because what we do is go 11 minus 1, that's 10. 10 divided by 2 is 5, so that gives us 5 terms. The middle term. So the middle term, what we do is we go 11 plus 1 is 12, divided by 2, that's 6. So the middle term is 6. Okay? Everyone's happy with that? Do you want to practice another one, or you're okay? You're okay. Okay, so this type is called arithmetic. Arithmetic means adding. So this is called adding because each time, this is going plus 2, plus 2, plus 2, isn't it? Now I want to show you a different type. This type goes like this. 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. Okay, what's happening here? From here to here, what's happening?
Times 2.
Times 2, isn't it? Times 2. And from here to here, times 2. So each time, it's times 2, isn't it? So what I can say is this is 2 plus 2 times 2 plus 2 times 2 times 2, isn't it? Okay? We have a neat way of writing this, haven't we? We can say this is 2 to the 1 plus 2 to the 2 plus 2 to the plus 2 to the 4. How many terms do we have? 1, 2, 3, 4, 5, 6, 7. So we go 4 raised to the 5, raised to the 6, raised to the 7. Okay, so that's a very neat way of writing it, raising it to a power, isn't it? Okay, so the last type, where we just add a fixed amount, we call that geometric. This type, where it's multiplying by a fixed coefficient, we call this geometric. Now, I will explain later why it's geometric, because geometric we think of shapes, don't we? You might think, why? I will show you later why, it will make sense. But at the moment, we just call this, okay. Now, let's try another one. So this one is getting bigger, 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 isn't it? What's happening here? 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus 1/64 plus 1/128. What's happening here? Okay, so this one here, we can write this in our summation notation, can't we? N is 1, and we're going to count through to 7, aren't we? So we put our 7 up here. So then we put our n term, isn't it? Our n term is 2 to the n, isn't it? Okay, so that's telling me that every term is going to be 2 times bigger. What's happening here? To go from a half to a quarter, what's happening? Times. Yes, well, I can just say times 1/2. From here to here, times 1/2, isn't it? Times 1/2, times 1/2, times 1/2. Okay, so this could be written like this, couldn't it? 1/2 raised to the 1, raised to the 1, plus 1/2 raised to the 2, plus 1/2 raised to the 3, dot, 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 all the way up to 1/2 raised to the 7. Happy? So, using our same summation notation, we use our capital sigma. N is equal to 1, counting through to 7. And we can go brackets 1/2 raised to the 7. So, raised to the n, sorry, you are right. Raised to the n. Happy, happy? Okay. So, let's imagine we have a square. A square like this. Now, I'm going to cut it in half. Okay, so this is a half. Okay? Then I'm going to cut that in half. This is a quarter. Yes? Have you seen this before? Then this becomes 1/8. Then this becomes 1/16. This becomes 1/32. This becomes 1/64. This becomes 1/128. Okay? Now, what will happen? This is a bit like this summation here, isn't it? This summation. If I make this summation n to infinity, it's the same thing, isn't it? Here I'm adding a half. Here I'm adding a quarter. Here I'm adding an eighth. Each time it's just a part of this big square, isn't it? Okay? Does anybody know what this will equal?
1 minus 1/.
This will equal 1, isn't it? Because this is a whole unit, isn't it? Okay, so this is part of the reason why they call this geometric, isn't it?
But I think we can't. So maybe or where there must be a rest.
So if we go to infinity, infinity is a very big number. Let's check this on the calculator. Let's come over here. Okay, so we come up here and we so we go n is equal to 1. N is equal to 1. And then we go counting through to infinity. Come down here, and then this is 0.5, which is a half, raised to n. So we are predicting this should equal 1, shouldn't it? It should equal 1, shouldn't it? So let's hit enter to see whether my calculator agrees. 1. How's that? In a flash, it added all those infinite terms up, didn't it? Okay? So this brings up an interesting point, doesn't it? This one here, it's times 2. It's getting bigger and bigger and bigger and bigger. If it goes to infinity, it will end up being infinity, won't it? This one here, it's times 2 times 2. Each time it's getting smaller, 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 until infinity will approach 0, won't it? So we're adding almost 0, almost 0, almost 0. So we call this converge. So these converge on a number. These have a limiting factor, don't they? So if our base, if this base number here is less than 1, it will converge, won't it? It will get smaller and smaller. If our base number here is bigger than 1, it won't converge. It will just keep on getting bigger and bigger, won't it? That makes sense? Okay, that's good. Okay.